Okay, in this week we need to talk about the operator overloading. Okay, I will explain the project at the end of this lesson. Right? Okay, Feyzullah. So, in Python, we have the sum methods to be utilized in class implementation in order to overload some mathematical operation or some specialized operation. For what? For each variable or the instance. Okay. This is called the operator overloading, and there are many operators, such as the for example, we can define the plus with the add function, or right hand add function, or the pos function, or we can define the multiplication operator by using the mul keyword, or right hand mul keyword, or we can subtract any data by using the class structure like this one. And this is the whole operation related to what I copy of the whole this codes in here like this one, and then this is overloaded for the what? For each instance or the variables or a specific class. Okay, and so if I have this code in my class implementation, and then I can plus or add the any two instance to the another one. Okay. But how can we implement this structure? Firstly, we can create some class like this one, the class numbers. We can give the init function body like this one, and so can give the arguments of the number in here, and self number can be assigned with the number. Okay. After that, we can define the another function in here with the self parameter like this one, the print self and number. Okay. And so what is operator overloading? Overloading like this one, we can define the sum these double underscore functions like this one with the parameters of the self and x, and we can return to the what? The number self number plus x number. Okay. Because this self indicate the what? The class instance of the number. Okay, and so this self possess the number variable in here like this one, and so if we add the any instance with another one, and then we should give or take the values of the what? The x dot number like this one. Okay, so or firstly we can give the what? The number 10, and for the y number 2. Okay, and after that we can define the x plus y, and so we can print the z or the z number variable in here like this one, and then we will get the what? The number values like this one, 30. Normally we have the error code in here if we don't have this property like this one. Okay, because the unsupported operand type is for plus number and number, which means that this is not to be what? To be add to the another term, and we cannot assign to the any variable in here like this one. But if I have this operator overloading mechanism, and then I can reach the whole the values from the what from this one. So also we can define the another property in here with the str or string keyword in here, like this one for the double underscore terms, and we can return to the what the str values of the what self number. And so if I call this print z function body, this returns to the what to this function, and then I can reach the whole the values from the what 30. Okay, this is what the operator overloading mechanism of our Python programming language. Okay, this is the basic feature for the what for this time. Okay, and so all the basic type, for example integer, double, or character or string, are defined by using these terms. Okay, and so what we can define the another property in here, like this one. This add can be changed with the sub, and we can assign the minus, and this add is changed with the multiplication operator, or this add can be changed with the true div variable in here. Okay, this is the division operator for the what for our class. Okay, and so if we have this property, we can multiply with the what these terms, like this one, y times x. Okay, and so if I multiply these terms, and so this 3 is assigned to the what z values, or we can divide all the terms with the what with the y value. Okay, because we have the true division values in here, like this one, and then we will have the 1.5. okay, and so normally we don't have the any utilization property for the number, but or the unless if we have the operator overloading function like this one, the add, sub, mul, true division, or the str, and then we can assign or we can apply the some mathematical operators to be defined in this function on the what on these results. Okay, this is called the operator overloading. Okay, any question? Okay, if there's no question, we can define the x is the what the number a, and y is defined number b. Okay, and so this is what this is the R definition. And so if I run this code and then we don't have the any error, because this a is passed to this number, because we don't have the any knowledge about these things, because if we have the integer or the double or the float value in here, we should assign it. But if we have the string character in here like this one, there is no syntax error, because this number assigned to the string, and then this string can be overloaded by using this function. But if I apply this property in here, and so this z equal y plus x is assigned to the what to this one. But if I print this code we will have the b and a, which means that this b is combined or collected with the a character. So this is not a number operation, and in some cases there is a some error syntax in here, because we don't have any runtime error or the syntax error in here. But how can we remove this property or prevent this situation in the what in our definition? Firstly, we need to give the class number in here like this one, and so we can give the def init function body in here with the parameters of the number, and then the self number is assigned to the what the self number, and then what this condition must be changed with the what with these terms. For example, if is instance, this checks to the what the number of the what integer or float. And so this is instance function returns to the boolean values true or false for the what if the number is assigned or is equal to the what the integer type or the float type. This is true, and after that we can assign this term like this one, and so we can give the else function in here like this one, and then what the number must be number. Okay, for example, if we have the x value in here like this one, the number AC and y yes, and then if I run this code, and then we have this warning, number must be number or the integer or float values. Okay, so we can prevent this error situation by using this kind of function definition. Okay, and then what if we have this property, we can give the add function in here like this one, self and x, and so if is instance can be add with what the x values in here like this one, and integer and float can be given in here, and then the return the number is the what the self number plus x. Okay, because this x is given in the what is the integer or the float terms, but otherwise is true, and then we should give the what the self number plus x number, because this x is the instance of the this values, but in this case we have the what the normal integer or float values, and so we can assign this x with the what with the number, because we have the property definition in here like this one. We can check these terms, and this is what can be supplied by using this function. With the same analogy, we can give the sub in here and also we can give the what the mul and times can be given. Okay, and after that we can also give the what the true division operator with the what with the self and x values, and if instance x integer or float value in here, and also x must be what must not be equal to the what the zero value, because this is the what the division by the zero values. This is the error case for the maths. Okay, and so if this is not true or this true, x is not equal to the 0, and then we can return to the what the number self number divided by x. Okay, else we should give the what the print values number must be non-zero values. Okay, and also we should give the return values in here like this one, and this is not the true, the is instance integer or float, and then what if x number not equal to 0 and then we can return to the what the number self number divided by x and number, and otherwise the print to the what the number must be non-zero value in here. Okay, this is what the division by 0 can be prevented by using this kind of operation. Okay, this is a huge advantage for the what for our algorithms, because we can assign to the any class to the specific basic type, for example the number or the complex number or the float number or the double number. Okay, or we can write the rational numbers. Okay, so this def is assigned in here like this one, and also we should give the def str value, the self and we can return the str self number. Okay. So this is assigned with what, the 10 and 20 values, and z can be assigned with what, the x divided by y, and print z value can be given in here. And so this is equal to 0.5. This is true. Okay. But if I assign the y is the what, the number 0. Okay. And after that I can calculate the x divided by y, and also I can give the print z value in here like this one, and so the number must be non-zero and returns to the what, to the non-values. Okay. Or I can give the what, the y is equal to the 0, and y can be assigned in here. And also this is the double check for the what, for our algorithms. Okay. This is what, or this is how I can specialize all the class or this number or the functions by using these terms. Firstly, you need to understand that we can define the integer values in here like this one. If I go to this definition by pushing the control and left button in here, and so these int values can be defined with what, a new parameter, real, imag, numerator, denominator, and the other parameters given in here like this one: add, sub, mul, floor division, true division, mod division, div mod, or blah blah blah. Okay. All the operators are the what, are overloaded in the what, the integer values, float values, and so all the integer values is a class instance like this number. Okay. So any question? So if there is no question, we'll continue with what, the class rational properties or the function body. Firstly, how can we define or create the class property like the integer or the any other class definition values in the Python? For example, we can create a class to produce the what, the 3 divided by 2 or minus 1 divided by 10. Okay. I can give this property by using the what, the operator overloading mechanisms. Okay. And so how can we do that? Firstly, we need to import the math for the specific operation. Okay. Or using the what, the some specific constant values, and after that I can define the class rational body in here like this one. Firstly, we need to give the initialization function or the what, or constructor function. Right. And so if not is instance a, an integer, is true, or not is instance can be given with a b, integer, and then I can throw the error type, the type error function in here like this one, and so numerator and denominator must be integer. Okay. These are the properties for the what, for the rational class. Okay. Because in the rational number we have the whole the time is the what, this time we have the integer values, positive or negative. It doesn't matter. But otherwise, if the b is equal to 0, for example, this 3 divided by 2 is equal to what, 3 divided by 0. This is the what produced the infinity values. Okay. And so this is the what, the value error. Okay. For example, denominator must be non-zero. Okay. If this is not the case, and then I can give the self A, self B, B, and also I can give the self simplify function body in here. What is this simplify? This simplify is implemented by us in the later of this code, okay? For example, if we have this kind of definition in here like this one, firstly we need to give the rep r function body in here, and then the self is assigned in here, and self b is equal to the 1, and so return to the what, the str self a, okay? And after that, if self a is equal to the 0, whatever, this is the 0, because if we have the 0 values in the numerator, and then we will get always the 0 value for the rational numbers, okay? And then what? This is the what, the general representation of the R body. For example, this is the self A divided by self B, okay? And so in each time, these rational numbers returns to these values or these forms, like this one. And so if I use this rational class variable or the instance, and then we will get these values in these formats, like the str function bodies, okay? But in order to simplify our code, we can give the what, this code like this one, self this one, gcd is the math, gcd, this is the greatest common divisor, which means that we have the simplest form of the what, the rational number. With the two parameters in here like this one, and then this self a must be given with the what, this term, and this self b must be integer division gct, okay? This simplify is utilized in here at the what, at the constructor of this rational function body, okay? And then what, we have this nomination in here like this one, that we can create the add operator overloading mechanism in here like this one. And so if is instance can be given by r and integer values, okay? Every rational number must have the integer values at the what, at the numerator or the denominator, okay? And so this a can be calculated with the what, the r times self b plus self a, and this denominator is the what, is multiplied with the right hand side values plus self a. This is the simple mathematical rules for what, for obtaining the what, the rational number calculations, okay? And also we can give the b values as the self b because it's the denominator, okay? Otherwise we should give the what, the self a is the self a times r dot b, because this r is also rational number, okay? Plus self b times r dot a, and also b is self b times r dot b, okay? And after that we can return to the what, the rational a and b, okay? This is what the result of the summation or the adding operation in the what, the rational numbers. And also we can add the what, r at, which means that we have the rational number at the left hand side or the right hand side. This r at, the reverse at, which means that we can take the parameter at the right hand side with what, left hand side, and so this is the reverse order operation, okay? For example, if I use this syntax, firstly, z is equal to the rational number blah 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 plus 5, okay? This is what the standard add function is utilized in here. But in the second case, we have the 5 values in here and plus the rational blah blah blah, okay? This is the right hand side. This r is represent these terms. Okay, just remember that. So in the subtraction operator we have this definition. Sub can be assigned in here like this one. R self A, self B is same, and this term must be subtracted with another term. Okay, and after that the AB is returns to the what with the rational number property in here, and also we can give the R sub and sub values. Okay. It's the same analogy for the what, for the add operators. Okay, so after that we should give the what, the mul function. Self R is given in here if is instance value R is equal to the what, the integer type, and then A is equal to what, self A times R, and B is equal to the self B. Okay, but this is not the case, or the rational number is given to the R parameters in here with the R, and so the A self A times R A, and B is the self B times R B. Okay, and after that we can return to the what, the rational number constructor with the parameters of the A and B. Okay, and after that we should give the reverse operation with the what, with this definition. Okay, and this mul is assigned to the what, the R mul parameter. Okay. And after that we can create the def value through div values in here like this one, the self and R parameter if is instance values R is equal to the integer type, and so A self A and B and self B times R. Okay, this is the division operation in mathematical notation, but this is not the case, and so there are two rational number in here, and A is assigned with what, the self A times self or R dot B, and B is equal to what, the self B times R A. Okay, after that we should return to the what, the rational number with the what, the A and B. Okay. After that we should give the R true div function body, true div assigned to this one. Okay. This is the simple but the highly efficient method for the what, for the overload the any function or the any properties in what, in R class. Okay, and beside of these terms we can assign to do any other variable in here like this one. For example, LT is overloaded. It's a comparison operator for the what, for the operator overloading mechanism. Its instance can be assigned with what, the R integer value, and return self A is smaller than self B and also R. Okay, or it's not the case, and so return self A divided by self B and RA divided by RB, which means that this LT represents the what, the given parameter is greater or smaller than this term. If the R or the right hand side values is greater than this term, this returns to the true values. Okay, and so with the same analogy we can derive the another functions in here like this one. LT can be defined in here, and LE is defined with the what, these terms self A divided by this term and equal to this one. Okay, and self A and self B is greater or equal form. Okay, greater and equal. Okay, and also we can define to the another function like this one. This is the GT. Okay, and what is GT? GT is equal to the what, the self A and self B, and greater than R value. R is integer, okay? But in the other case, we have the greater value, but in this case, the left hand side is greater or not, okay? This is the what, this is the condition of the what, the comparison operator of this term. Like this term, we have the GE value, greater or equal terms, okay? And so we can assign the equal in here, and we can assign the equal in here, like this one. Or we have the this is equal or not, like this one, and so this equal or not, okay? This simple notation. Or not equal form can be overloaded, like this one, any not equal and not equal, okay? But in this case, we have this property in here, like this one, because we have the rational number in here, and so this must be what the other terms of our properties, okay? And after that, we can convert the whole terms with the definition of the float values in here. Firstly, this is the overload function, and return to the self A divided by self B is the definition of the conversion of the float value. This is the type conversion operator overloading mechanism of the R class. Or we can overload the integer definition, like this one, return self A, but this is the true definition in here, self B, okay? And after that, we can convert the terms in here, like this one, the bool function, self, and return self A not equal to 0 returns to the what? This is the bool value, because this not equal to 0, and then this returns the true values. Otherwise, it's false, okay? So it's the long code, but I can drive this term like this one. That we have the rational number in here, for example 3 and 2, and y is equal to the rational number 1, 2. Firstly, the result is given by the x, and plus y can be given with the result values of this term. 3 plus 1 is 4, and this is the denominator, and so this must be give to the 2 value. Voila, okay? Or we can create the result value x divided by 2, and print results can be assigned with with this term, like this one, 3 divided by 4, okay? Or we can convert to our result by using the float term in here, result value, and then we can convert this term like this one, and so this is the 0.75, okay? This is the float value, but in the upper code 3 divided by 4 is a rational type, but this float is the float value, okay? Or we can convert to the to integer values like this one. And so the integer values returns to the 0 value, because 0.75 equals to 0 in the integer type, okay? Or if we have these z values in here, like this one, or the z is equal to the rational number with the empty parameters, when the empty parameters is given, this is the is the default constructor. A is equal to 0, B is equal to 1, which means that 0 divided by 1, which means that it's equal to the 0, okay? And so this z can be assigned to the true values, okay, or the print or the wrong values, okay, in the other case. Z is equal to 0, and so this is not the true, and so this is the false value, okay? And after that, we can assign to another term, like this one, the rational 1 divided by 2, and rational 1 divided by 2. Firstly, we can give the x greater than y, which means that this function is overloaded in here in the comparison operators. And then what? We can generate the output of this code like this one, the print x greater than y, okay? Or if x smaller than y, and so we can print to the what? The x smaller than y, okay? If x is equal to the what? The y, and print x equal to the y. And so what's the result of this code? This result of this code, x is equal to the y. But if I change the x to 3, and so x greater than y, or I can assign the 4 values in here, and so in this case y is greater than x, okay? So these are the general example of the what of our rational number bodies in the what Python programming language. All the basic types of the Python is created by using these function body notations, okay? And so you can easily adjust or create your own class for a specific purpose. For example, in your mechatronic engineering application, and then you can specialize for the what the integer values or the float values or the any other numbers, okay? Like this one. So x3 and in the x4 we need to talk about the any other properties of this overloading mechanism. For example, the class sample is created with the parameters of the def init function body like this one, okay? The self with the parameter a, and self a is equal to the a, and after that I can define the add operator overloading function self with the parameters of the s, and so if instance is instance as sample, and then return to the sample values of the what the self a plus ss, okay? And then if is instance s is equal to the integer value, and so the return to the what the return sample self a plus s, okay? Def str self the return values of the what the f is equal to the what the number of the what the self a, okay? Which means that if I call or create this sample body and add the any other variable in here, all the number is seen on the page of the what in the format of these terms. For example, if I have the a value with the 10, s is equal to what the sample of the 10, okay? And so this print to what the s or this the result value can be created to what the s plus a, and then I can print the result of these terms. Normally we have the what the 20 values, but in our overloading mechanism the number 20 is seen on this page, okay? But if I change this condition like this one, the result of a plus s, in this case we have the right hand side at the what at the sample, and so this unsupported operand type is seen on the what on this integer and the sample, which means that we shall give to the what to the any other function in here in terms of the what the def are at function, okay? The self a, and we can print the what the are at function like this one, and we can return to the what the sample of the what the self a plus a, okay? this equal to the what? This another terms are at, and also this is given to the what, to at, and also this at is added in here. Okay, and so if I run this code, and then we will have the r at this times s plus a. Sorry. And so in this case, firstly, this s plus a calls the what, the add function, only add function. But in the second term, we get the r add function. Okay, you get it for the total points of this code. You get it, the utilization of this implementation in here. Any question? If you don't have any question, and so I need a 20 minutes break, and then after that at the 5 we will begin to the another examples of the what of the operator overloading mechanisms. Okay.